Hey everyone, welcome back to Rocks for Jocks. My name is Alex Chansky, and yeah, I'll be your host for the show. This week, I'm talking about some natural hazards that were going on in Japan. There was an earthquake and a tsunami, and some advisories about a possible mega earthquake coming up in the next few days. So, yeah, I want to talk a little bit about what all of that means for Japan. What does it mean for earthquakes and tsunamis? And just disaster preparationness in general. Yeah, it's a good one. I think you're gonna like it. If you do like it, make sure to subscribe wherever you're listening. Send this episode to a friend and go subscribe on Substack. The account is Rocks for Jocks on Substack. Super easy to find if you just give that a quick Google. Yeah, go subscribe on there. It's got some figures and slightly better explanations, but I wanted to record this and put this out in a podcast form as well. Yeah, just go check it out. It's a good one. So today I wanted to talk about Japan having a big earthquake on Monday, April 20th, 2026. It was a 7.4 magnitude off the coast of northern Japan. This was a big deal for a couple of reasons. It triggered some shaking alerts. It triggered a small tsunami. And it also set off an advisory for a possible mega earthquake later this week. Events like these can raise a natural question for us all to talk about, which is that does one large earthquake signal something bigger to come? And yeah, that's kind of what I want to talk about today. So, earthquakes and their associated damage are really hard to predict for a couple of reasons. We can estimate which ways the Earth's tectonic plates are moving if we zoom out enough to see things geographically, or we zoom out enough to see things on a long enough time scale. Those tectonic plate movements become really clear and obvious. But on shorter time scales or like more precise geographic locations, it's kind of hard to pick out exactly where and when those tectonic plates slip past each other violently enough to shake our world. Some of that plate movement on the like smaller local scales are a little bit randomized, and just harder to predict in general. So what do we know about tectonic plates? So we know that stress can build up over time and is released at irregular intervals by all of those tectonic plates that push and pull against each other. We can map where strain is very likely accumulated and be able to give you long-term probabilities of where slips might happen. But pinpointing those exact locations, or the exact timing, or the exact magnitude of a rupture is challenging. It's a little tough. So that's why earthquake, quote, advisories, unquote, give probabilities of an event happening rather than a prediction of a specific upcoming event's strength or location. In this piece, I want to break down what this recent earthquake does and does not tell us about the likelihood of possible future events. Let's get into it. For every 1 unit increase in magnitude, such as going from a 3.0 to a 4.0, an earthquake releases roughly 30 times more energy, but it only occurs about 1/10 as often. While that phrase, larger less often, might sound obvious, this rule of thumb relationship ends up being really important because it generally holds true across both different regions and also different time periods, allowing us to estimate when and where some earthquakes might be more likely. Those earthquakes then happen in clusters, meaning that if we have a large enough sample of events, we can compare the observed distribution of magnitudes and frequencies to what this relationship predicts it would be, and then see how closely reality matches those expected patterns. Let's say we go to a new country and we don't know anything about their earthquake history. If we measure a bunch of 3.0 magnitude events in that region, we can be reasonably confident that they get 4.0 magnitude events at around 1/10 the frequency that they get 3.0. And then the next step would be saying that they get 5.0 magnitude events at around 1/100th of the frequency that they get 3.0. Even cooler, this relationship holds true across time periods too. If we observe a bunch of small events in a short period of time compared to the number we typically see, That suggests a higher chance of a mid-sized event happening soon. And then if that cluster grows into including several mid-sized earthquake events, then the likelihood of a larger event increases. So generally speaking, when counts of a certain magnitude grow larger than their usual baseline in that local area, earthquake event patterns tend to ramp up from the high number of small events to a few mid-sized events, peaking with one or two large events, and then kind of tapering back down through the mid-sized to the smaller events again. So that means if we saw a cluster of events in Japan with magnitudes at 7.0 or above, we would raise the odds of a few even larger events happening. So events that were maybe magnitude 9 and above, for example, those would be considered really large compared to all the 7.0 ones. Because we only saw one event greater than magnitude 7 and a few others between like 4.5, 5.5, that region, we can say that a large event is more likely than usual, but still pretty unlikely. Seismologists basically look at the same number of earthquakes that I'm talking about here. They look at it with more rigorous math and logic than when I'm describing this, but they basically look at and see the number of earthquakes of different sizes that have happened nearby and try to determine if we are continuing to ramp up, what the probability is of having earthquakes that are still ramping up and going beyond that magnitude 7.4. And that's how they estimate the chance of a magnitude 9 or greater event in the next week. They estimate that at around 1% probability compared to a normal week, where a normal week would rank it at around 0.1%. So basically what they're telling us is that by observing this pattern of events in the range of magnitude of 4, 5, 6, 7, by observing that current pattern of events that we're seeing, we can that increases the likelihood of a magnitude 9 or greater event tenfold over the next week. So overall, it's still a really low probability of it happening at around 1%, but 10 times more likely than it would be in a normal week. All right. So moving on. What happens when the earthquakes actually strike? So Japan this week registered magnitude, depending on what scale you use, it was 7.4, 7.5. And that was off the coast of northern Japan. It was at a depth of around 10 kilometers. Sadly, us as humans, we're not yet able to predict earthquakes in advance. So that means we have a really short time period between when an earthquake starts versus when people and infrastructure take damage if they're close enough for the waves to impact them. That's because waves propagate outward from a certain source. They naturally lose their strength as they spread across more area as they get further from the source. All that means that if you're close enough for earthquake shaking waves to actually hurt you, you're probably going to have a really short time period in which to be warned. Of course, how far the event actually is then makes it a big part of the formula for how long it takes the earthquake shaking waves to get to you. For example, if the epicenter of the earthquake event is right underneath your feet, you're basically going to have 0 seconds between when the earthquake starts versus when the area you're sitting in starts taking damage. Those waves reach you pretty much right away. If the epicenter of the event is 200 kilometers away, which is about 124 miles, the earthquake's first shaking waves will get to you within around 30 seconds. And then the stronger secondary waves get to you around 20 seconds after that. So that means most of the events that cause damage are going to hit population centers in under a minute, leaving very little time to spread word and get people to prepare once the shaking starts. All of that put together means that we're much better off knowing what earthquakes are going to happen in advance. But as we already discussed, predictions for earthquakes are really, really hard. In general, as humans, we're pretty good at giving broad probabilities of when the events are going to happen. but not good at specifics of exactly where and when and how strong. So it's not perfect by any means, but this at least gives people some level of preparation for when the worst events are more likely to happen. On a side note, I wanted to talk about tsunamis for a minute as well. Monday's earthquakes caused a really small tsunami, which had a highest measurement that I saw of 80 centimeters, 2.6 feet, at the Kuji port. When earthquakes happen offshore, it's not always clear until later on exactly how big the tsunami is going to be. So a general warning was issued that the wave could have been up to 3 meters tall. That's 10 feet tall. Yeah, and I just thought that was a good reminder that even though tsunami damage is not necessarily likely or probable in every event, it's absolutely possible in addition to like the primary shaking damage and then secondary damages like liquefaction as well. Yeah, and just consider ourselves happy and lucky that the tsunami didn't actually reach that height. But just making sure to keep that all in mind for things like insurance purposes and safety systems. So, what can we do about all of this? How should we react to these earthquakes happening or not happening in different regions on different days? A few different places have started sending out alerts to either everyone with a smartphone or everyone with a certain app on smartphones to give you almost immediate alert as soon as giant earthquakes get set off. So in California, the state of California started an alert system. The United States Geological Survey started an alert system. So giving people even just 10 to 20 seconds to prepare for earthquake shaking to hit them will almost certainly save lives as large events continue to strike, which we know that they're going to over the course of our lifetimes. Even just that 10 to 20 seconds can really easily help people get out of buildings if it's possible, or if it's not possible, to at least get under cover and protect themselves from shaking objects, maybe get off the road if they're driving, that kind of thing. Alternatively, we can also use past events to tell people when events are likely or probable to strike compared to normal weeks. So, as I was talking about earlier, that's why Japan said there's a 1% chance for a mega-quake off the coast of northern Japan in the next week. This means for every 100 times an advisory is issued for a possible magnitude 9 mega-quake, we expect it to actually meet or exceed that threshold once in the following week. For some comparison, in normal times we have a 0.1% chance of mega-quake happening off the northern coast of Japan. So that would be the event happening once out of every 1,000 weeks. So to recap, the comparison is once out of every 100 weeks during the advisories versus once out of every 1,000 weeks in normal times for the mega earthquake to strike. Is that a perfect prediction? Absolutely not. But what it does is it keeps people on their toes for the next week while the largest... Is this a perfect prediction? No, absolutely not. But what it does do is it keeps people on their toes for the next week or so, while the largest events are more likely than normal. Maybe people in northern Japan stock up on essentials like food and water. Maybe they remind their kids about finding cover or staying out of buildings if shaking starts. Maybe they double check that their first aid kits or fire extinguishers are up to date. My point is, a mega-quake is still pretty unlikely in the next few days, but flagging that it's more likely this week than usual gives people another chance to prepare in case disaster strikes. Hey everyone, if you've listened this far, I really appreciate it, and I would love if you were able to send this episode to a friend and subscribe to my Substack. It's Rocks for Jocks is going to be on Substack.com. Just give that a quick Google, and I'm sure it'll pop right up. Thank you again for listening. Send it to a friend, and enjoy the rest of your day.